Hello, everybody. I said Peter Nolan from MasterCard, good partner with the Databricks team. I'm based in Dublin, Ireland, in our European Tech Hub. I lead our software engineering team in the R&D division. Today is my 12th anniversary of MasterCard. Thank you. I literally got a notification this morning through our HR system going, happy anniversary. So 12 years is a long time to be in a company, but I literally have the best job at MasterCard. The team I work in, we're responsible for evaluating emerging technologies like GenAI, which is super exciting. We were jumped on it as soon as it got launched, just over 2 years ago. We do look at other technologies. We're looking at quantum, so really interested in what's happening this week with AWS and what they're doing in that area, privacy and tech, et cetera, et cetera. So, but GenAI, super hot topic this year for us. What we do is, jumping on the slides. Yeah, so we do a lot of research, obviously, but the best part of the job is actually taking that research and applying it to product development. So we're not just stuck in the lab playing with toys. We actually work with teams across MasterCard who might have a new idea, like the one we're going to present, around how to apply that technology to one of their business solutions. So we actually build the solution in a kind of a lean startup methodology, rapidly bring it to the customers and test with them at an MVP level. How do we do that in a large company? As you can imagine, MasterCard security is top of the pops for us. So platforms and services, something my team actually run ourselves. We have our own cloud platform. We manage it ourselves, and we actually have our own instance of Databricks. What that allows us to do is deploy these applications rapidly and securely to MasterCard standards, but also to experiment at that early stage and inform the rest of the company on our learnings. So GenAI, obviously like a lot of companies out there, we're looking at one of our first use cases after doing lots of experimentation. The first one we have was that customer service agent, and we had a really good use case where we have a team that helps customers with their onboardings to some of our products, which can be quite complex, a lot of configurations, and takes a lot of time to onboard and work through the different settings. So we have a dedicated team that manages these customers. Why it was a really good use case is because it's measured. Really, that team just they get the support request in, they're measuring the time that we answer the customers. Sometimes the agent just doesn't have the knowledge. So they're going back to the subject matter experts, could even go back to the engineering team. That's a ticketed process. And of course, with tickets, there's SLAs. And suddenly a simple question that could have been answered very quickly if you had the knowledge is turning into a multi-day process. Not a great experience for our customers. So we said, let's build our first production application. And we didn't want to do this just a one-off, let's build it. We've all built loads of prototypes. I think we talked about it earlier. You can get up very quickly with some of the RAG systems that have an agent. But that wasn't going to be what we wanted. We need to build something that was more of a platform. We had about 50 products just in the onboarding use case, but there's lots of other use cases bubbling up around MasterCard that we wanted to be able to service with a single solution. We also, as I said, we're hands-on. We want to learn these technologies. So let's build something from the ground up and really understand how do we build these things in production? What's the SDLC for GenAI app? How do you integrate it into our development processes? How do we test? How do we roll back? All of these typical software engineering questions. And lastly, a common theme today is we wanted to make sure that what we built is quality. So how do we then automate the improvements to the model that we've created? How do we bring those subject matter experts into the project with us to help us create this system and keep improving the accuracy of the model? So what did we build? So nice conceptual architecture, nice and high level for the talk. On the left side, we call our model factory. One of the decisions we made was to have multiple models per domain. Domain is a collection of knowledge. The knowledge is coming from lots of unstructured data. There's emails, there's a ticketing system, Q&As back and forth between the agents. There's all our documents, some in PDFs, some on web portals. So quite a diverse set of information that need to be pulled into a model domain. Multiple reasons for that. One of the biggest reasons was that in MasterCard terminology overlap. So a token in our MDES product, which is the thing that powers Apple Pay, Google Pay in your phone, is very different to a token that's running on an e-commerce website. So we need to be able to split the domain knowledge into different bundles. Also for the development lifecycle, we have different teams working on different models, so it's much easier to split that up. So we needed a way to build that, and that's what we're using with our Databricks. We're using the model serving that was just mentioned, and the vector index for our RAG data. Now we have a nice model. That's great. We have our own API layer that's talking down in the Databricks model serving API and our own UI. So our agents are using the system, but how do we improve it? And that's where we have the similar human-in-the-loop system. So through our UI, agents can interact with the system, but they're part of this pilot. So we're asking them to help us improve things. So through the UI, they have a simple thumbs up, thumbs down. They also have the ability to edit a question. So if they think the answer coming from the model is incorrect or maybe missing information, or sometimes even just too verbose, so we need a more concise answer, they can edit that in the UI and save it. Those edited answers are the ones that are graded, go into a back-end system. This is where the subject matter experts come in. They then log into the same UI, and they have a job to go through all the graded questions and have a second pair of eyes on them. They can also edit them. They can manipulate the answer. And then once they've verified it, it's then stored again and used for training data. So now we have a human in the loop grading all the questions and creating a nice set of data that we can feed back into the model. A lot of automation kicks in, and we're creating the new model and deploying it. But how do we know that that model is actually better? So that comes into the LLM as a judge. So we're using a very similar system where the judge is then asking the model a bunch of questions. So at the beginning of the project, we had hundreds and hundreds of questions from our customers, and we roped in lots of SMEs to go and answer those questions for us. So we have a nice kind of golden set of evaluation data. We used the LLM as a judge to ask the model a question, and through a prompt, we're now evaluating whether the response was good. And the response could be good where it's answered the question, but maybe it's coming back with an unprofessional tone, so then we downgrade those answers. So we score the response between a 1 and 5 metric. Then once it's graded, we get an overall score for that model. And then through automation, again, we're going saying, okay, is the new model the score higher than the previous one? If it is, then we swap them out and promote the new model to production. So that creates that continuous flywheel. And we've started with, I think we were in the low 60%, our score from our evaluation from the judge, and we're now up into the high 80s. So we're really seeing that improvement. This is since July when we launched to around now that we've been able to bring the quality of the model back up. There's a talk there mentioned there of the fine-tuning API. So that's something we're experimenting with now, is trying to optimize what we have. So we have a couple of things we've looked at. We're using the fine-tuning API to do exactly that, to use a smaller foundation model and make sure or see if we can then tune it to have the same efficacy score that we're getting from the RAG model. And we're actually seeing amazing results. So really excited to start building that into the system. We're also doing just some simple optimization. So we're using the vector index for what it does, which is good similarity searches. And through the agents, they will pick a question it's perfect. So it's a verified question. It gets flagged. So rather than going back to the RAG model to generate the answer, we're actually just pulling it directly out of a cache in the vector store. So that's a really good optimization that we're seeing. All of this is wrapped in typical software engineering practices. So we're using Git and Git Flow and Jenkins integrated into the Databricks system through their CLI to actually automate a lot of these flows back and forth. So for example, if someone tweaks the system prompt, just like any code, it's a PR request, it gets code reviewed, the review gets accepted, Jenkins kicks in and calls into the Databricks system. Databricks pulls down files from Git, and the automation kicks in, and a new model is built, and the testing flywheel kicks in. So this is really, we found amazing results. The team who are using it love it. It's a tool for them to get through the day faster. They're not spending all day doing queries and tickets, so they have a lot of other things to do. So being able to speed up that process has been amazing for the agents. Now, I was double dared to do a live demo. Right, here is our landing page. As you can see, it's pretty, I think. It looks pretty good. We're treating this as a product for our customers. Even though they're internal at the moment, we do plan to bring this external to our customers to use. But right now, it's an internal product, but we're still treating it as a product and getting a lot of feature requests from the users. Let's sign in. Fingers crossed.
Demo gods.
Excellent. So here we are, very familiar interface. There's a pattern forming with ChatGPT and others. The home screen has some kind of standard kind of prompts. We're in training mode with the agents, so they're getting familiar with the tool, so they can see kind of some examples here. This is built for a specific workflow. So I'm going to do a very quick run through a workflow. So an agent will get a ticket in. They'll start a new chat. They're going to pick a product from the list. So we've got 3 products live at the moment, and this is at my stage environment, so it's not production. It's going to be assigned to a ticket. So they're going to be working on a ticket that they'll be familiar with these numbers, so we don't need to have extra context here. The agent will know the ticket they're going to work with. So I'll try John Doe, see if he's alive, and we'll start the chat. Excellent. So nice, simple interface. I mentioned earlier in the talk MDES. It's one of our products. So why don't I ask the system, what is MDES? What is MDES? OK, can I beat 30 seconds? I can. Excellent. So here's an answer, very concise. MDES is the MasterCard Digital Enablement System. I should have asked if anyone knew what it meant. And it's not a physical card, it's a virtual card kept in our mobile device. So we have a few features to show you here. The first one is that we have the link to the data that was pulled out of the vector index to see what collection of data came up with the answer. So that's very useful for the agents, and then also they can click on it. And this is a really big feature that we didn't even think they'd necessarily like, but they're able to just follow the thread into the documentation, and they're building up their own knowledge. So this one actually came from our public developer portal. So a part of our factory there building the models actually scraped this website for that information and pulled it into the vector store. So that's nice and neat. Another one to show you is this is where our human in the loop system starts. We have, as I said, a simple thumbs up and simple thumbs down, and then the ability to edit the question inside the UI. So I won't edit this. This is a nice, concise answer, but as you can see, you could edit it and submit the update. So here we go. This is the interface. It's nice and simple. There's a few kind of extra features on the side, but it really is just keeping it tight to what the user needs. Now, a different persona. This is the SME, so the subject matter expert. They can come in, and I have this role to the admin portal. Now, their job is to, there's some reports and things in there, which is quite nice. You can see how the system is performing and how many answers are being graded. But their job here now is to go through some of these questions that have been submitted. So I'll start reviewing. This is like kind of whack-a-mole. I can just kind of keep going in and answer these questions. It's quite cathartic. So here's a question here. You can see some information, some metadata. I can actually see the chat history. And this is important because a lot of them are like this. So it's not kind of question, get the answer. The agent doesn't know the answer, so they're trying to interrogate the system to get to an answer. So as the SME, I can see what was the original question, what was the back and forth, and I can say, OK, is the final answer the concise answer to this question? If it is, then I can actually accept it, and it now is marked for training data. And then you can see it just slides onto the next question, and it's back and forth. So once this is done, training data, I think we run it nightly, get all the verified answers, and the flywheel starts to improve the model. And that is my demo. Thank you.